So section 7.3 is assessing normality, and basically in a nutshell, guys, everything that we've been given, we have been told, assume X is normally distributed, assume X is normally distributed. 7.3 is if you were given data and not told that it was normally distributed, or your data that you collect, you don't know if it's normally distributed. This would be a way to test that it was normal, because if it was not normal, we couldn't do any of this stuff. Okay, so what we do is, it's called a normal probability plot, and I try my best to explain it, but what it is, it's a graph that plots the observed data value versus its normal score. So basically, the observed data value, that's your x-axis, and that is literally x, your data value, and then your y value is the z-score. Okay, so what it does is it assumes that everything's normal. And so it go ahead and it found the mean and standard deviation, and it finds the z-score for every x value and plots it, okay? If the expected z-score of an observed value depends on, what was I going to say? Oh, here, the note is what I was going to talk about. So that's the plot. Why do we care about it? Because it says if we take the sample data and make a normal probability plot, it will be approximately normal or linear if it's approximately normal. So hold on, let me write it down and you can write it. So it will be approximately normal if it's linear, okay? So if your normal probability plot looks like a hot mess, okay, it's probably not normal data. But if you plot your normal probability plot and it kind of follows the line like chapter 4, it would be considered approximately linear, which means it's approximately normal. So looking at this, I don't know. Say this is the times to run, I don't know, 200 meters when you're in junior high or something. I don't know if that's right or not. I didn't do track. Okay, so assume these are the scores to run a 200 meter dash when you're in junior high. And so these are times from 31.2 seconds to 32.6 seconds. What they would do is whatever these values are, they would find the mean and standard deviation, they'd find the z-score for each, and they would plot them. So notice the average was probably around 32 or so, because anything less than 32 had a negative z-score, anything more than 32 had a positive z-score. What we care about in general, do you guys think that this follows a line? Like, remember chapter 4? Would you say in general that follows a line? Okay, so that means, so the question is a set normally distributed? Since it's approximately linear, comma, it is approximately normal. Okay, my math lab usually has like these outside bounds. Okay, so if you fall within the outside bounds, you are not being linear, so you wouldn't be normal. And again, the whole idea is now that we know this is approximately normal data, we can do everything that we just did in section 7.2. So why did I pass out this guy? Because this is how you can find a normal probability plot. So let's just do it real quick. Get your calculator out. So these are our times. So what we're going to do is we're going to go to our list 1. We haven't been in our list for a while, since chapter 6, okay? So we're going to go to list 1, clear it out, and type in these values. So 31.26, 31.35, 31.91, 32.006, 32.37, 32.52. Okay, once you have them in there, what we're going to do is we're going to turn on our normal probability plot. So we're going to go to second y equals, and all mine are off, which is good for now. Okay, I'm going to hit 1, and I'm going to make sure on is highlighted. Okay, so I hit second y equals, and I want to make sure on is highlighted. So I'm going to hit enter, and what we want is we want this graph that's over here, but if you arrow down, it drops to the X list, so you're actually going to arrow to the right all the way over to the very last graph and hit enter. You say yours isn't doing it? someone say that? I'll come through around to make sure everything looks okay. So what you do is you have to arrow to the right. You can't arrow down. So you arrow all the way to the right until you get to that graph. They want to know what list is your data in. It's in list 1. Your data axis is going to be on X, and then it just lets you pick what mark you want. I picked the little square. And so then we can hit graph. And I hit graph and I don't see anything. But if you hit zoom 9, you should see it. And so notice that's that exact same graph that we had on here. And I'll walk through you. And guys, honestly, it's not that big of a deal. Because I think on your homework, I don't know how many of these you have. But again, once you graph it, if it follows a general line, that guy's a little far out, but everything else follows that general line. Since it's approximately linear, you would say yes, it's approximately normal. Okay? So when you're